continuing on with 11.2 on arithmetic sequences and series. We're now on example 5, and before we're talking about the sum of those arithmetic sequences and series. So when I see this, first I have to decide before I do this problem, is it even arithmetic? And we start at 4, and then 7, then 10, then 13. Is it going up by the same number every time? Well, to me it looks like it's going up by 3 every time. So since it's going up by 3 every time, I know it's arithmetic, which means I can use this formula. But the question is now stating, find the sum of the first 30 terms. So if I wanted to, I could sit there and get out my calculator and do 4 plus 7 plus 10 plus 13 plus 16 plus 19 and keep going till I have 30 terms there, press enter and get my answer. That will give you the same answer here. It really will. However, what if I said find the sum of the first 130 terms? If you want to sit there and do that, be my guest. I know that I'm not going to do that. I'm going to use the formula here in order to solve. So let's find out what the equation is first when we're doing this problem. And I know that the first term is a sub 1, so I can plug a 4 in there. I know that d, now the constant term, is 3 because it's going up by 3 every time. And since it wants to find the sum of the first 30 terms, I could eventually figure out what n is from there, but let's just distribute, and we're going to find out what the actual equation is. This is how easy it is to find an actual basic equation for this formula right here. We know it was 4, distributed that 3 through because that's the common difference. Combine my like terms, I end up getting 3n plus 1. That is the equation for the problem. So the problem now is, it says, so what's the 30th term? I can't do this problem because according to that equation that we just talked about, that sum of arithmetic sequences and series, I need to know the first term, which I do, and I need to know the last term. Well, the last term is the 30th term. So to figure out what the last term is, I need to plug a 30 in for n. So 3 times 30 plus 1 is 91. So now that I know what the first term is, which is 4, and now that I know what the last term is, which is 91, I can use this formula. I can plug the first term in, which is a 4, plug the last term in, which is 91, and I want to know the sum of the 30 terms, so I have 30 there in the outside for m. So I add those together, divide by 2, then multiply it by 30 to get 1425 is my answer. So find n such that S of n equals 175. What this is saying is, let's work backwards. Now we're going to use what we just talked about. It's the same example, so I still have the same formula. Okay. What we're saying here is that a sub n is 175. What that means is we already know what our sum is. Alright, so I can plug that in right here. 175 goes in here. A sub n, I know what that is. That's 3m plus 1. So I can plug that item in right here. And we know what the first term is. It's 4. That's how I plugged all these in. I know the last term, which is right here. I know the first term, which is 4. And a sub n, the last term, is 3m plus 1. So I can plug that in right there. I combine my like terms to get 3n plus 5 over 2 times n. And what I can basically do now is I can distribute that n through. That's like saying n over 1. So the bottom is just 1 times 2, which is the same 2. But the top, n times 3n is 3n squared. N times 5 is 5n. So to solve that problem, what I need to do now is I need to get rid of that fraction. So to get rid of that fraction, since I have a 2 in the bottom, let's multiply by 2 on both sides. So by doing that, I end up with 350 equals 3n squared plus 5n. I'm looking at something that we remember from chapter 5. I'm looking at a quadratic equation. So why don't I combine all the terms onto one side, which is why I subtract the 350, and I end up with this equation. I can use the quadratic formula in order to solve this problem, and when I plug it into the quadratic formula, if you remember, that's negative b plus or minus the square root of b squared minus 4ac divided by 2a. If I use that formula, here's what I get. 2 answers. I want to know what number of terms add up to be 175. Well, a number of terms, as in I could have 1 term, I could have 8 terms, I could have 20 terms. I can't have negative 35 over 3 terms, right? It has to be a natural number, right? It has to be a certain number of terms. So 10 is the only answer that we have for this problem. So this answer doesn't make any sense. 10 is the answer to the problem. So example 6 here. The first row of a concert hall has 25 seats, and each row after the first has one more seat than the row before it. There are 32 rows of seats, so we want to write a rule for this. Okay, so we want to know what it starts with. That's the only way we can solve this problem. Well, actually, it's pretty simple. A sub 1, what it starts with is 25 seats, because the very first row has 25 seats in it. And I want to know what D is now. What's it going up by every single time? Well, it says we're adding one more seat to each row. So, what that means is A sub 1 is 25, and D is 1 because that is what I'm adding, one seat to each row. So I distribute that through to get 25 plus n minus 1. So I end up with n plus 24. That's my formula. So what that means is, whatever I plug in for n, if I say, well, how many seats are in the 10th row, I just do 10 plus 24 and I get 34 as my answer. I could tell you right now there are 34 seats in the 10th row. So there's our rule to find the number of seats per row. But example 6 says I want 35 students from a class and they all want to sit in the same row. So how can I fit them all in the same row? Well, here's what I need to do. I know 35 seats, right? I need 35 seats total per that row, so I put a 35 in for a sub n, and I solve that to find out, well, it'll all work out for you if they sit in the 11th row. Now, they could sit back farther than the 11th row, right? They don't have to sit in the 11th row. They could sit in the 12th or the 13th or the 14th row. That's fine, but they can't sit any closer, because if they do, there won't be enough seats for them to sit together in the same row. So there's your homework. If you have any questions or concerns, please feel free to email me. Otherwise, I hope this was very helpful and enthusiastic for you.